Hey, welcome to Chemistry with Taylor E. Today we're going to do some Lewis dot structures just for individual elements, and I'll throw ions in there too. Not of ionic or covalent bonds or anything like that yet. We're just going to focus on Lewis dot structures for an individual element. Make sure you understand the trend and how many dots, right? How many electrons that every element is supposed to get, okay? So Lewis dot structures, it's basically drawing dots for the electrons, okay? So every time you see a dot, you're going to see an electron. So you might have an example, for example, neon, right? And there's dots around it, okay? This is a Lewis dot structure for neon, okay? And those dots all represent valence electrons, which are the outermost electrons, okay? The outermost electrons, the valence electrons, are the ones that we really care about in chemistry because they're the ones exposed to the world, right? When elements bond, it's because of those outermost electrons, okay? These are all hiding inside, right? They're covered, they're protected, they're the core. But on the outside, so this outermost electron, for example, sodium here, you can see in this outer ring, right, it has one valence electron, okay? And so if I were to draw the Lewis dot structure for sodium, then I would put sodium in the middle in its symbol form, and then one singular dot representing that one valence electron that sodium has. Now, the cool part is the number of valence electrons that an element has depends on its group number, right? So in other words, a column, right, which is up and down on the periodic table. So you can see here I have this quick little thing that I kind of drew up, right? All of the elements in group 1 on the periodic table have one valence electron, right? VE stands for valence electron. The minus is because electrons have a negative charge. Group 2 on the periodic table, right? Those have two valence electrons. Transition metals, right? Those are going to change. Those are going to vary. We don't really have a set pattern for those. I call transition metals the fake people of the periodic table because they act different depending on who they're with, right? So depending on who they're bonding with, they change. So to ignore the transition metals for this case. You go to group 13, so this is where boron starts, right, on the periodic table. So boron, aluminum going down. They have 3 valence electrons, 4 valence electrons, 5 valence electrons. You're seeing the pattern, 6, 7, and 8, right? So ending with our noble gases, they have 8 valence electrons. And again, if you remember, if you have heard of the word octet, an octet is 8 valence electrons, and that is the most stable configuration. That's what elements want at the end of the day. So the noble gases were born with that, right? However, they got here on Earth. That's how the noble gases came with 8 valence electrons, which is why they are considered to be so noble, right? So that is the valence electron trend. So it goes 1, 2, skip the transition metals, don't worry about them. 3, 4, 5, 6, 7, 8. Okay, so just like that, very simple, very sweet. So you can see also one thing I want to mention is this is group number 13, but they have 3. Group 14 has 4. Group 15 has 5. So when you get to the 13 through 18 groups on the periodic table, subtract 10 basically, just ignore the 1 in the front. Because again, 8 valence electrons is the most that you're going to have when it comes to this trend. Okay, you're not going to have 13, 14, 15, 16 valence electrons, all right? So let's go ahead and practice, okay, now that we have that idea down. So draw the Lewis dot structure for the following. So if I were to be given calcium, another way your worksheet might word this is electron dot structure, so very similar as well. So calcium, right, I would find calcium on the periodic table. It is here in group 2. So that means it has 2 valence electrons. So I would put 1 and 2. You want to put them like up, right, bottom, left, right? Kind of like around the circle basically. So 1, 2, 3, 4. There's going to be little patterns and tricks that we use to put these dots and place them accordingly, but this works for now. 2 dots, you're good to go. So 2 valence electrons. Number 2, nitrogen. I'm going to go to nitrogen on the periodic table. I can see that it's in group 15, which means that it has 5 valence electrons, right? So 5. So again, we're going to go 1, 2, 3, 4, and now I'm going to double up into 5. And so there's nitrogen's valence electron structure. For some reason, these are my favorite. They're the most appealing to me. I don't know, just something about the visual of it. It looks very symmetrical, but I like group 15's Lewis dot structure. Number 3, we have oxygen. So I'm going to find oxygen on the periodic table. It is in group 16, so it has 6 valence electrons. You're going to draw, it's going to help you down the line to draw the group 16 elements almost as if they're like a Humpty Dumpty Mr. Potato Head type of idea. So they have like, like 2 head, like a head, feet, and like arms, like on the side. Because you're going to notice oxygen loves to have something bonded on the left and the right side of it. And so doing it like this, when you get to the bonds and more elements added in, it's going to save you some time. So I like to draw the group 16 elements in this configuration. But if you drew it in a different way, it's okay for now. I tell my students, as long as you don't have more than 2 in each spot, and you have the correct amount of electrons, you're good to go, okay? All right, number 4, we have hydrogen. So hydrogen is the first element on the periodic table in group 1 on the periodic table, so it has 1 valence electron. So you can put it up top, you can put it to the right, either way, whatever floats your boat. Number 5, we have barium. So I'm going to find that on the periodic table. It is right here in group 2. Barium has 2 valence electrons because it's in group 2. So 1 and 2. All right. Number 6, xenon. Getting a noble gas in here. Xenon, again, is in group 18. So that means it has 8 valence electrons. So I'm going to go ahead and just fill those in. 1, 2, 3, 4, 5, 6, and 7 and 8. Right? There you go. All right, number 7, we have aluminum. So we're going to find Al on the periodic table. It has 3 valence electrons because it's in group 13, right? So group 13. So I'm going to go 1, 2, and 3. Number 8, we have an ion here. How do I know we have an ion? Because of this 2 minus, right? That's a charge, right? That's a -2 charge. So that means that sulfur normally has 16 valence electrons, right? But it has a -2 charge. If it has a -2 charge, that means it took in 2 more electrons because electrons are negative. So if it has a negative charge, it has to take in negativity, right? And electrons are negative. So it had, right, again, it had 16, right? Group 16, it had 6 valence electrons, but now it's going to be 6 plus 2. So it's going to have 8 valence electrons. So I'm going to draw sulfur with 8 valence electrons. This is an ion, so it's customary to put it in brackets with that -2 charge, okay, in the top right-hand corner, okay? All right, number 9, we have carbon, a very, very popular one. Carbon here in group 14, so that means it has 4 valence electrons, okay? And I'm just going to put 1 around each side. Nice. All right, pause here, see if you can do them, 10, 11, and 12. These are all ions. See if you got them. Otherwise, keep watching. We'll do them together. All right, number 10, we have Br minus 1, okay? So bromine, that means it normally has, right, 7 valence electrons, but it is a -1 charge, so that means I'm adding an electron because a negative charge means electrons are negative, so it's taking in electrons. So that means that bromine also now has 8 valence electrons. I'm going to put those around, 3, 4, 5, 6, 7, 8. That is not by happenstance that after these 2 ions they have 8 valence electrons, not a coincidence, okay? There's a reason for that. Again, if you remember me mentioning at the very beginning of the video, elements want octets. That's what they have their ion charges for, is to gain that octet, and so there's a trend within that, okay? Number 11, we have K plus 1. K normally has 1 valence electron. If it has a +1 charge, then that means it lost an electron, it lost a negative particle to be positive, so technically, right, we just kind of draw our K. It had that 1, but it's gone, and so K with the +1 charge there, okay? It lost that 1 valence electron. P minus 3, so phosphorus minus 3. So if I go to phosphorus on the periodic table, it's in group 15, so that means it has 5 valence electrons, okay, normally, but this is an ion. -3 means it gained 3 electrons, right? Because electrons are negative, so 5 plus 3, there you go. There's that number again, 8. So I'm going to draw phosphorus, 1, 2, 3, 4, 5, 6, 7, 8. Put it in brackets and showing that -3 charge in the top right-hand corner. All right, well that is Lewis dot structures for individual elements and ions. Next, you would be doing ionic bonds and covalent bonds, so bringing more elements and rules and a fun time into the mix. So I'll see you on the next one.